Hi everybody and welcome. Today we're going to be doing a little bit of a review for our quiz, so taking a look at some of the proofs that we've gone through this unit. So to start off, we are looking at an algebraic proof to begin. So let's write that down as our given statement, so what they give us here. And then let's go through and solve this problem like we would for any normal algebra problem, but just making sure that we're doing the same thing on all the sides. So on the left side here, we're dividing by 5, so maybe we can multiply everything by 5. We'll be left with 2x minus 9 equals 5. And again, we multiplied everything by 5, so that is the multiplication property. And after we multiply, maybe we can go back through and add 9 to both sides. So we'll be left with here 2x equals 14. Again, we added to both sides, so that is our addition property. And then our final step here, let's take this, divide both sides by 2, and we'll be left with x equals 7. We divided both sides, so that is going to be our division property. We got through, we proved our final answer, and we're in good shape. All right, a little bit more challenging going to our geometric proofs now. So starting off with our given statement, AC equals BD. Again, they give that to us in the question. So from A to C is equal from B to D. Next, AC equals AB plus BC, BD equals BC plus CD. That looks like we're just splitting up these lines into that part plus part equals whole format, so we can use our segment addition as our reasoning. And again, if we look back to our table, I think that was in 3.2. I'll look back to our table of notes from 3.2. That was basically saying that we're allowed to split up lines into part plus part equals whole, and the reason that we're allowed to do that is using segment addition. Next, we know that AC equals BD. We know what AC and BD equal, and it looks like we're setting what AC equals equal to what BD equals. So that is our transitive property there. Basically, we're substituting in known statements in place of AC and BD. And then finally, going back and doing a little bit of algebra here, subtracting BC from both sides, and we'll be left with just AB and CD. So that is our subtraction property. Awesome. So a little bit of geometry, a little bit of algebraic reasoning there, but again, using what we have in our tables to help us be successful. And a final one, let's look at some angles here. This one's a fun proof. I like this one. So 1 is equal to 2, or congruent to 2. Those are vertical angles, so that is the definition of vertical angles. Again, right across from each other, right on top of each other. That's one of those things we don't need to prove. We know that's true. That's a definition. All right, give it 2 equals 3. So 2 and 3, those are equal to each other. Let's highlight those just so we can see them. Boom. 2 and 3, those are equal to each other. So let's write that on in. That's our given statement. And then next, angle 3 is equal to angle 4. So 3 and 4, those are the same. So we can say again, by that same reason we used to begin the definition of vertical angles, we know that that is just true if they're on top of each other, that they're the same measure. And then finally, we're saying angle 1 is equal to angle 4. All right, so let's see if we have enough of the reasoning here to get to that point. So we know that angle 1 is equal to angle 2. So that means that angle 1, if angle 2 is equal to that, it's also equal to angle 3. And we know that angle 3 is equal to angle 4. So it looks like we just proved, okay, so angle 1 is equal to 2, angle 2 is equal to 3, angle 3 is equal to 4. So by that, 4 and 1 are linked in that way. So again, if, let's say the measure of 1 is 5, that means 2 is 5. And then if 2 is 5, that means 3 is 5. And if 3 is 5, that means 4 is 5. So all the way back to the beginning, we're saying that 1 is equal to 4. And that is our, again, transitive property. Big jump there, but pretty cool to see why alternate interior angles have the same measure. And we actually just proved that using a proof. So 2 and 3, those are alternate interior angles. We're saying that they're equal to each other. And by using this, we'd actually be able to prove that these lines are parallel. So pretty cool stuff. A couple things that we can reach based off our conclusion, but we're only looking to see that 1 is equal to 4. Those are actually, alternate exterior angles. So we did a little bit of work there, and we're in good shape. So again, as always, just rely on those notes, those charts that we used for reasoning, and you'll be in good shape.